Picture this. You're watching a nature documentary and David Attenborough's soothing voice tells you about elephants talking to each other from miles away or dolphins chatting with their podmates. You nod along thinking, oh yeah, animals definitely have their own languages. I mean, it seems so obvious, right? Birds chirping at dawn are clearly having their morning gossip session. Your dog barking at the mailman is obviously giving him a piece of his mind, and those whale songs, well, that's gotta be some kind of underwater poetry slam. But here's where things get interesting. Scientists have been wrestling with this exact question for decades, and the answer might surprise you. Are animals really speaking languages to each other, or is something else entirely going on? Some researchers claim they've found evidence of animal names, complex grammar, and even dialects. Others argue that what we're seeing is something fundamentally different from human language. The debate has gotten so heated that it's split the scientific community down the middle. But what if I told you that bees can give GPS-precise directions through interpretive dance? That dolphins actually do have names for each other? That elephants might be having conversations we literally cannot hear? The animal kingdom is buzzing with communication, but whether it constitutes language in the way we understand it opens up one of the most fascinating debates in science. Are we anthropomorphizing animal behavior, or are we finally cracking the code of nature's most sophisticated communication systems? Now, let's start with what makes this question so tricky. When scientists talk about language versus communication, they're not just splitting hairs for fun. Communication is everywhere in nature. A peacock's elaborate tail display communicates, hey ladies, check out my jeans. A skunk's distinctive black and white stripes communicate, back off or you'll regret it. But language, well, that's a whole different ballgame. Human language has some pretty unique features that scientists call design features. We could talk about things that aren't right in front of us, like planning tomorrow's lunch, or reminiscing about that embarrassing thing we did in high school. We can lie, create abstract concepts, and even negate things by saying not. But here's where it gets fascinating. The more scientists study animal communication, the more they're finding behaviors that seem to challenge these supposedly human-only features. Take dolphins, for instance. These aquatic acrobats develop what researchers call signature whistles, essentially their own personal names that they use throughout their entire lives. When a dolphin calls out with its signature whistle, it's basically saying, hey, it's me, Flipper. And what's even more remarkable is that other dolphins can learn and use these names to call specific individuals. Imagine if you could whistle your friend's name across a crowded room and they knew exactly who was calling. And the research gets even wilder. Scientists have found that dolphins don't just use these names randomly. They'll call out their own signature whistle when separated from the group, essentially saying, hey guys, I'm over here. They'll also copy the signature whistles of dolphins they're bonded with. Think of it as the dolphin equivalent of calling your mom. And here's the kicker. Researchers have proven that dolphins can extract identity information from these whistles even when all voice characteristics are removed. It's like recognizing someone's handwriting even when you can't see the actual pen strokes. Now, if dolphins have names, surely other animals must have developed their own versions of language, right? Well, let's take a trip to the hive and meet nature's most precise communicators, honeybees. These little engineers have developed what might be the most sophisticated non-human communication system on the planet. When a scout bee finds a good nectar source, she doesn't just come back and buzz excitedly. She performs what's called the waggle dance. And this isn't just cute animal behavior. This dance is essentially like a GPS system with interpretive choreography. Now check this out. The angle of the bee's dance relative to vertical tells other bees the direction to fly relative to the sun. The duration of the waggle run indicates the distance. A dance lasting 1 second means the food source is about 1,000 meters away. The intensity of the dance tells other bees about the quality of the food source. It's like having a restaurant review, driving directions, and a distance estimate all rolled into one rhythmic performance. Recent research using computer algorithms to decode bee vibrations has revealed that bees communicate through dozens of different movements and sounds. Waggling, knocking, grasping, piping, trembling, and something wonderfully called intonation. Scientists are now using artificial intelligence to decode these communications, and have even started working on building artificial bees that could theoretically communicate with real hives. The complexity doesn't stop there, though. Different bee populations have developed their own dialects. Bees from different regions perform slightly different versions of the waggle dance, suggesting social learning and cultural transmission. Some researchers argue that the bee dance language is the most complex symbolic system humans have successfully decoded in the animal world. But perhaps the most mind blowing animal communicators are the ones we can't even hear: elephants. Those gentle giants of the savanna and forest have been having long distance conversations right under our noses, or rather, right under our hearing range. In the 1980s, researcher Katie Payne made a groundbreaking discovery. She noticed that sometimes when she was around elephants in zoos, she felt a strange rumbling sensation in the air, almost like standing too close to a massive stereo speaker. It turns out elephants communicate using infrasound, sound frequencies so low that humans can't hear them. We're talking about frequencies as low as 1 hertz, when the lower limit of human hearing is around 20 hertz. These infrasonic rumbles can travel for miles. Scientists have calculated that an elephant's call can potentially reach other elephants in a 50 square kilometer area. During certain atmospheric conditions, particularly in the evening when temperature inversions occur, this range can expand to an incredible 300 square kilometers. That's like being able to have a conversation with someone in the next town over. The sophistication of elephant communication rivals anything in the animal kingdom. They have different types of rumbles for different situations. Greeting rumbles when family members reunite, contact calls to coordinate movement, and even specialized feeding calls that help coordinate group foraging. Some of these calls have remained stable across multiple generations. Elephant families have been using the same vocal traditions for decades. Now, what's particularly fascinating is that elephants don't just communicate through the air. Their low-frequency calls also travel through the ground as seismic vibrations. Elephants can feel these vibrations through specialized receptors in their feet and trunks. They can even determine how far another elephant is based on the time difference between the airborne sound and the ground vibrations. Now, let's shift gears and let's talk about our closest relatives. If any animals were going to develop human-like language, you'd think it would be other primates, right? Well, the story there is both fascinating and frustrating. Monkeys do have surprisingly sophisticated communication systems. Diana monkeys, for instance, can combine different calls to create what looks suspiciously like sentences. They have specific alarm calls for different predators, one for eagles, another for leopards. But here's where it gets interesting. They can actually modify these calls with additional sounds that seem to function like grammatical markers, adding meaning like maybe or not urgent. They can even understand the calls of other monkey species, essentially making them multilingual primates. Campbell's monkeys take this even further. They have a basic call system, but they can add a suffix sound to modify the meaning of their calls. It's like adding ish to English words to make them less definite. Some researchers argue this demonstrates the rudimentary form of grammar. But here's the limitation that researchers keep running into. While monkeys can't combine two elements in their communication, they seem to hit a wall there. As one MIT study put it, there's, quote, two and infinity, unquote. Monkeys can handle simple combinations, but they can't do the recursive, open-ended combining that defines human language. We can nest clauses, within clauses, creating potentially infinite sentences. Monkeys seem to max out at simple two-part combinations. This brings us to one of the most beautiful and complex animal communication systems in the animal kingdom, birdsong. Now, scientists have found that songbirds share some remarkable similarities with human language learning. Like human children, young songbirds learn to sing by listening to adult models during a critical period. They go through a babbling phase where they practice and refine their songs. Some species even have regional dialects. Birds in different areas sing slightly different versions of their species' songs. Similarities run deeper than just learning. Recent research has shown that some songbirds can learn to modify their songs contextually. Bengalese finches can be trained to change specific parts of their songs in response to visual cues, essentially learning to say different things in different situations. Once learned, they can switch between these song variations instantly and maintain the behavior without reinforcement. What's remarkable is that songbirds have specialized brain regions for vocal learning, similar to the language areas in humans' brains. They even show lateralization. Different sides of their brains handle different aspects of song production, just like humans have language lateralization. But here's a crucial difference that researchers keep coming back to. While songbirds can learn complex songs and even modify them contextually, their repertoires are still limited. A typical songbird might have 5 to 12 different syllable types that they can combine in various ways. Compare that to the roughly 50,000 words in the average adult human vocabulary, and the gap becomes clear. So, where does that leave us? Are animals speaking languages to each other? The honest answer is, it depends on how you define language. If you define language strictly by the criteria that linguists have traditionally used for human language, infinite creativity, abstract reference, complex grammar, the ability to discuss things that aren't present, then no, animals don't have language in that sense. They have communication systems that are sophisticated, sometimes remarkably so, and they're fundamentally different from human language. But here's where the scientific community is getting interesting pushback. Some researchers argue that these traditional definitions are biased towards human language and might be missing the point entirely. They suggest that we've been studying animal communication through the wrong lens, looking for human-like features instead of appreciating the unique solutions different species have evolved for their specific communication needs. The field is experiencing what some scientists call a paradigm shift. Instead of asking, do animals have languages like humans? Researchers are starting to ask, what can animal communication teach us about the diversity of possible communication systems? This shift has led to discoveries that would have been missed under the old framework. What's becoming clear is that animal communication is far more sophisticated than we previously imagined. Elephants communicate through rumbles, vibrations, and maintain multi-generational vocal traditions. Dolphins use names and can even learn the names of other dolphins they've never met. Bees can communicate precise spatial information through dance. Whales have cultural transmission of songs that change over time. And some populations share song elements across vast ocean distances. Perhaps the most important insight from all this research is that communication and cognition aren't the same thing. Just because an animal doesn't express complex ideas doesn't mean it doesn't have them. As one researcher put it, animal communication systems typically only express a small subset of what that species knows and can think about. Think about it this way. Your internal thoughts are infinitely more complex than what you actually say out loud. You might be thinking about 17 different things while having a simple conversation about the weather. The same might be true for animals. They might have rich internal lives and complex thoughts, but lack the communication systems to express all of that complexity. This realization has profound implications. It suggests that the gap between human and animal cognition might be smaller than the gap between human and animal communication. The question then becomes, not are animals smart enough for language, but rather, why did humans develop such an elaborated communication system when other intelligent species didn't? The answer might lie in our unique social needs. Humans developed unusually complex societies that required precise coordination across large groups. We needed to share abstract ideas, plan for the future, and build on each other's knowledge across generations. This might have created evolutionary pressure for increasingly sophisticated communication that other species simply didn't face. So, this was a wild one. Do animals speak a language to each other? The scientific consensus is evolving, but here's what we can say for certain. Animals have developed remarkably sophisticated communication systems that are far more complex than we previously understood. While these systems might not qualify as language by traditional definitions, they demonstrate cognitive abilities and social coordination that would have seemed impossible just a few decades ago. Rather than asking whether animals speak a language the same way humans do, like, hey, how's it going, and, how's Janet doing? Maybe we should be marveling at the incredible diversity of solutions that evolution has found for the universal challenge of communication. From chemical signals to infrasonic rumbles to interpretive dance, life finds a way to share information, coordinate behavior, and maintain social bonds. So, the next time you hear a bird singing or watch bees returning to their hive, remember, you're witnessing millions of years of evolutionary problem solving in action. It might not be language as we know it, but it's something equally remarkable, a testament to the power of communication to connect minds across the vast diversity of life on Earth. Now, whether your dog is actually trying to tell you something important when he barks at 3 a.m., or he's just commenting on that suspicious-looking raccoon, well, that's still up for debate. Thank you so much for listening to Fool's FAQ. Feel free to leave a 5-star rating wherever you get your podcasts, as it also helps new listeners discover the show. For more fascinating answers to your burning questions, subscribe wherever you get your podcasts, and always stay curious.